Welcome to the Explainer. Today, we're going to do something really cool. We're taking a completely normal manual test case, the kind of step-by-step instructions a person follows, and we're going to translate it into a powerful, automated script using Selenium. Okay, so let's set the stage here. On the one side, you've got your manual test. Think of this like a recipe written for a human chef. Simple, clear instructions. And on the other side, well, that's our goal, the automated script. Right now, it's just a big old question mark. Our entire mission is to translate that human recipe into a language a robot can understand.
So, where do we even begin? You might think we jump straight into writing code, but actually, no. We start with our source of truth. Before you can automate anything, you have to know exactly, and I mean exactly, how a human does it first. And this is our blueprint. This table is basically that recipe I was talking about. Every single action a person would take is laid out right here. Open the browser, go to this URL, type this username, this password, it's all there. Our job is to teach our script how to follow these instructions to the letter, flawlessly, every single time.
Okay, so before we can write the recipe, we need a kitchen, right? Every great script needs a home. So our very first practical step is to set up our workspace. For us, that means creating a new Java class inside our project where all our automation logic is going to live. Now, in the Java world, everything kicks off with this thing called the main method. The easiest way to think of it is like the front door to our program. When we run our script, this is the very first place it looks for instructions. All of our automation commands are going to live right inside those two curly braces.
All right, our workspace is ready. Now for the main events. Let's start translating those manual steps one by one into actual working Selenium code.
So first things first, you can't drive a car without keys, and you can't automate a browser without a driver. That first line of code, that's the key. It automatically sets up the right driver for Chrome for us. The second line, that's us turning the ignition, launching a fresh, clean browser window that our script is now ready to control. And check out how intuitive this next command is. We simply tell our driver to get a URL. That's it. This one line of code is the exact same thing as a person typing saucedemo.com into the address bar and hitting enter. Pretty cool, huh? Now for what is maybe the most important pattern in all of web automation. Before you can interact with anything on a web page, you have to find it first. Notice that pattern? Every single action, entering the username, the password, and clicking login, it all begins with that same command, driver.findElement. This brings up a huge question, though. I mean, a human can just look at a web page and see the login button, but a script just sees a bunch of HTML code. So how do we give our script the exact address for each element on the web page? And the answer is with something called locators. You can think of locators as a unique address system for every single element on a web page. It's what allows our script to pinpoint exactly what it needs to interact with. So a locator is essentially a query. It's how our script asks the web page questions like, hey, where is the element that has the ID of username? Or find me the button that has this specific name. It basically turns a human's visual scan into a precise code-based lookup. Now, Selenium gives us a whole toolkit for finding elements. The gold standard is usually by.id, since IDs are meant to be unique on a page, which makes them super reliable. That's what we'll use for our text fields. For the login button, though, we'll use an XPath, which is kind of like giving our script a GPS route through the page's code to find what it's looking for. And once we found our element, we can finally interact with it. The .sendKeys command simulates a user typing on a keyboard. So right here, we locate the element with the ID username, and then we send the text standard_user directly into it. And for buttons, it's just as simple. We use a locator to find the login button, and then we just chain the .click command right on the end. This performs the exact same action as a user moving their mouse over the button and clicking. So we've translated our manual instructions, we've written the code, now it's time for the payoff. Let's run the script and see our automated tester actually go to work. And there it goes. In just a few seconds, a browser window opens up, it navigates, it logs in. It's exactly like one mentor put it. You can literally see that it typed in the username, password, logged in, and closed the browser. Every single step from our manual plan, executed perfectly. So let's talk about the real payoff here. A focused human might do this test in, 15 seconds? Our script did it in 5.
Now multiply that time saved across hundreds of tests, running multiple times a day. That is the incredible power of automation.
But of course, this is just the beginning. The real magic happens when you move beyond a single script. Professionals start to externalize their test data, so no more hard-coded passwords. They use powerful testing frameworks to manage thousands of tests, and they build code that is clean, readable, and maintainable for an entire team.
So you've seen the blueprint. Take a manual task, give the script an address for each element, and translate the actions into code. You now have the fundamental workflow. So the only question left is, what's the first boring, repetitive task you're going to teach your new robot assistant to do for you?